Hello, welcome. So today we are going to talk about box and whisker plots and stem and leaf plots. So two different types of graphs that we can make that kind of describe our data. So before we get started, let's quick start with a warm-up. So if you could just take a minute, pause the video here, work out these problems, and then when you unpause, I'll have answers for you, okay? All right, so now that you have done your warm-up, check your answers. Hopefully you got the same thing. If you didn't get the same means, make sure you typed in your numbers really carefully into the calculator. Remember, your median is the middle number when you line them up from least to greatest. You want the one in the middle. The mode is the number that occurs most often, and the range is the biggest number minus the smallest. And then when you combine both of your sets of data, so your scores and your friends, again, to find the quartiles and the interquartile range, you line them up from smallest to biggest, and then the median is the middle number, and Q1 is the middle number in the lower half of the data, like below the median. Q3 is the middle number in the upper half of the data, above the median. And then interquartile range is the quartile, third quartile, or the upper quartile minus the lower quartile. So, all right, what are we going to talk about today? We are going to talk about how we can take these numbers that we just came up with, and how are we going to display them graphically. So a couple different ways to display them graphically, but the two that we're going to talk about today is box and whisker plots and stem and leaf plots. So first, a quick definition. A box and whisker plot looks like this right here, and it uses what we call the 5-number summary to create a graphical display of quantitative data. Quantitative data just means like numerical data. So the 5-number summary is the minimum, or the lowest number, the lower quartile, or in other words like Q1, your median, also known as Q2, and then your upper quartile, or in other words Q3, and then finally your maximum. So box and whiskers are called box and whiskers because literally you have a box that you make with the Q1, Q3, and the median. And then the whiskers are this part that go out on the side. So before we really get started, one thing, really the only thing that you need to remember for the Keystone exam with box and whisker plots is that, remember we talked about like our chocolate bar when we found, quartile 1 and quartile 3 in the median? We talked about like our chocolate bar. So if we have a chocolate bar and we want to split it evenly into 4 pieces, what we could do is we could take our chocolate bar, cut it in half, that's the median, and then cut it in half again, that's Q1, and then on this side, on the right side, we can cut it in half again, that's called Q3. So remember, the quartiles, Q1, the median, and Q3, divide the chocolate bar into 4 equal pieces. So if I were to say what percent of the chocolate bar is in each piece, so there's like 25% of the chocolate bar in the first piece, 25% of the chocolate bar in the second piece, 25% in the third piece, and 25% in the fourth piece. So in other words, in each piece of the chocolate bar that you've now cut, you have 25%, right? So think about your data the same way. Between the minimum and the lower quartile, let me erase this real fast. So between the minimum here and the lower quartile, between those two numerical values, you actually have 25% of your data. And then between the lower quartile and the median, that's kind of like the second slice of your candy bar. You have another 25% of your data. And then between the median and the upper quartile, you have another 25% of your data. And then between upper quartile and maximum, another 25% of your data. Now, it might not look like that because you might say, but wait a minute, like this distance is a lot shorter than this distance, right? And that's okay because your numbers might be a little bit more spread out, but it still means that you have 25% of your data within each section. For example, our example that we looked at in last class, we had 12 total numbers. And we said if we have 12 numbers and we want to break off into groups of 4, so into 4 groups, right? We have 3 numbers per group. So what we're saying really is that within each section you have 25% of your 12 numbers. So between this numerical value and this numerical value, we have 25% of my numbers, or in other words, 3 of my numbers. Between Q1 and Q2, we have 3 numbers. 3 numbers. 3 numbers. Sometimes our numbers are just like bunched closer together, and that's okay. So what I just explained there, knowing that there's 25%, 25%, 25%, 25% in each section, that's the most important thing that you need to know about box and whisker plots on the Keystone exam. Let's look at a couple examples, okay? So an on-site computer repair company analyzed the data about the distance traveled for all repairs during a specific amount of time. So here's a box and whisker plot. So remember, this is like our 5-number summary. If I have to identify the minimum, the median, the maximum, Q1, Q3, that's our 5-number summary. So I can just look at where each of these values are. So right here, here's the minimum. So 0, 1, 2 on the number line. So my minimum is 2. Q1, so this is my min. Q1 is the bottom part of the box. So that's at 4. The median is always in the middle of the box. So that's at 10. Q3 is like the top part of the box. That's 16. And then the maximum is at 19. Make sense? So it's important to kind of like read off those numbers first. And then if we want to find the interquartile range, that's Q3 minus Q1. So the interquartile range there would be 12. Now, before we answer any of these questions that you see on the right-hand side here, these questions are asking about what percent of jobs are within this range and that range. All you need to do to answer these questions, all you need to remember is that within each of these sections, you have 25% of your data. So in other words, we're talking about distances traveled for repairs during a specific amount of time. So 25% of my distances are in here, 25% in here, 25% in here, and 25% in here. All right, so that's going to be really helpful for us. So let's look at some examples. Letter A, what percent of jobs are less than 4 miles away from the company? So I look at my number line, or I can look at the, 5-number summary numbers that I identified. 4 miles away from the company, that's right here, right? So less than 4 miles would be anything below that. So what percent do I have less than that? Just that 25%. All right? So that's part A. The answer is just 25%. Part B. What percent of jobs are between 4 and 16 miles from the company? Okay, so find 4. 4 was here, right? 16 miles was here. So I want what percent of jobs are between 4 and 16 miles. So this whole part in here. But it's the percent of jobs. Well, in other words, like how many sections? I have 25% here, 25% here. That's a total of 50%. Okay, let's try part C. What percent of jobs are less than 16 miles away from the company? So where's 16? Here's 16. Less than 16 miles would be anything below that, right? Well, how many sections do I have below this? Here's 25% here, 25% here, 25% here. Add those up. That's 75%. And finally, part D, what percent of jobs are more than 10 miles away from the company? So more than 10 miles away, well, 10 is your median. Remember, 10 is your median. That means it's your middle number. If it's in the middle, think about it, more than that, 50%. Or you could look here at your box of Whisker. What percent of jobs are more than 10 miles? So 10 miles or more. So over in these sections, here's 25% here in this section, and then there's 25% in this little section here, right? So 25 plus 25, 50%. So these, I always think, these look more confusing than they really need to be. Keep it simple, and remember, each part, in the Whisker it's 25%, and in each part of the box it's 25%. And then just add up the corresponding sections. All right. So please pause the video now, try these problems, and now you're comparing average monthly temperatures in 3 different cities. So some of these questions are going to ask about each of the cities, some of them are going to ask which has the smallest interquartile range, so you might have to do some math here to answer these questions. So pause the video, and then when you come back, I'll give you the answers. All right, guys, check your answers. Hopefully some of these, you can just kind of read off the numbers. You have to find the IQR by taking like Q3 minus Q1. You have to find the range from taking like the max minus the min. And don't forget the median is in the middle, right? Let's talk quickly about letter E, outliers. If you had any outliers on a box and whisker plot, it would look like this. Like, let me look at Seattle, for example. I have my box and whisker like normal, and then an outlier would be like another dot kind of out over by itself on its own. That would be an outlier, okay? So we don't have any of those, so we would say no, there's no outliers. And then the range, part F, the range of the upper 50% of temperatures in Seattle. Upper 50%, remember each section is 25%, so the upper 50% goes from 59 to 74 degrees, right? All right. So now let's switch gears a little bit and talk about what's called a stem and leaf plot. So a stem and leaf plot looks like this thing right here. Again, we're graphically displaying data, and we have, you're going to notice this big line down kind of the center here. The numbers in the left column, that's these over here, are what we call the stems. And then all these numbers in the right-hand columns, these are called the leaves. Okay? Now, before I go on any further, let me talk about what this actually means. There's always going to be a key with a stem and leaf plot. And so this that we're looking at are scores on a math test out of 70 possible points. So the key tells us that the zero is the stem, and then there's this line, 4 is the leaf. That means that you got 4 points out of 70 on the test, right? So for example, like if I just circle this 2 right here, this 2 matches up in the same row as the 5. So that means, I put them together, that means someone got 52 points out of 70 on their test, right? So in other words, there's a lot of, like here I see I have like 0, 0, 0. I see that 0 repeating 3 times. That means I had 3 students who got a 5, 0, put them together, who got a 50 points on their test, all right? One other thing that I want you to notice is that the leaves are all listed in numerical order. So when I have a lot of leaves, so when I have a lot of people who scored in like the 50s, right, between 50 and 59, they're all listed in order. So like 0, 0, 0, 1, 1, 2, 3, 4, you know, and so on and so forth. So those are all listed in numerical order. Let's look at some example problems. So here's that same stem and leaf that we were just looking at, same exact one, scores on a math test. So if we were to ask you what the minimum score was, the minimum score is the lowest score. Well, look, 0 is the smallest stem, right? So a 0, 4, or in other words, like a 4 is the minimum score. On the other hand, the maximum score is going to be in the 60s because 6 is the biggest stem, but then the biggest leaf that goes with that 6 is this 7 here. So that's a score of a 67. So find the median and the mode, okay? So the median. Remember, to find the median, you line up your numbers in order and you cross off the highest and the lowest until you get to the center. Well, the numbers are kind of already in order for you. So we're going to do that. Ready? If I cross off the lowest number, that's here. The biggest number we just said is 67, right? The next lowest is 23. The next biggest is 65. The next lowest is 24. The next biggest is 63. The next lowest is 26, and 62 is the next biggest, right? And now think about this. The next lowest after 26, I go to the 3 row, it's going to be a 31. The next biggest is the 60. So now the next lowest is 32. Think carefully about what the next biggest is. It's going to be in the 5 column, but is it 50 or is it 57? Right? It's 57 is the next biggest. So then 34, another 57, 35, and I'm going to keep going, crossing a small one with a big one, and then I get to 39 and 54, and then the next smallest is 40, 54, 42, 52. So the nice thing was that these numbers were already essentially in order for us. I'm getting down to the end here, right? So now I'm going to cross the 48 with the 50, and what do I have left? Here's my winner. This is going to be the median. Okay? So that 9, the answer is not 9, right? That 9 is the leaf. The stem that goes with that 9 is this 4. So my median is 49. My mode is the number that occurs most frequently. So hopefully your eye can kind of look at these numbers. Let me erase. I'm going to leave that median there because we're going to come back to that in a second. But let me erase all the rest of this stuff. And if you kind of just look, hopefully it pops out to you that you have a bunch of numbers that repeat. I have 2 4s, or in other words, like 2 54s. I have 2 57s. I have 2 55s. But here's the thing. I have 3 50s, right? So I have a whole bunch of numbers that repeat twice, but this one repeats 3 times. So therefore, the mode is just 50. Because that's the one that occurs the most times, right? All right, range. Remember, range is the biggest minus the smallest. So 67 minus 4. Are there any outliers? So an outlier is like something that doesn't fit the pattern, something that doesn't fit along with like the rest of your data. This person here, that score doesn't seem to fit along with everyone else. An outlier is normal. We can easily identify outliers by looking for any like gaps in your data. So if I have this big gap here between like all the rest of the data and this 4, typically we're going to call that 4 an outlier. And I'm going to say why, because there is a gap between the 4 and all other test scores. That's why that's an outlier. All right. Find Q1 and Q3. I'm sorry, that should say Q3. Let me change that to Q3. So find Q1 and Q3. All right, remember, Q1 is the middle of the lower half of the data. So essentially what I'm going to do is I'm going to find the median of everything below the median. So I'm going to forget about this median. Remember, that's where I cut my chocolate bar in half. And I'm going to find the center of the lower half. So I'm going to cross off the lowest, which is 4, with the highest number in the lower half, which is 48. The next lowest is 23. The next highest is 45. And then the next lowest, 24, 45, 26, 44, 31. Keep going. 34 and 41, 35 and 40. The next lowest would be 35, and the next highest one would be 39. So this 7, that represents my Q1. But remember, it's not really a 7, it's a 7 with a 3. So it's a 37. So Q1 is 37. And then to find Q3, you do the same thing, but again, for the upper half of the data. So start at the median, and you want to find the center of the upper half of the data. So the lowest number in the upper half of the data is a 50, and then the highest one is a 67. Another 50, a 65. Another 50, a 63. A 51, a 62. A 51, a 60. A 52, and now the next biggest one is this 57 here at the end of the row, right? And then 53, 57, 54, and then here we go. There's our winner. There's Q3. So Q3 is this 5 goes along with this stem, so Q3 is really 55. So the last question, question F. It says, what can you say about how students in this class performed on the test? So, in other words, overall, how did they do? I'm going to erase this so we can see this again a little bit better. But I would say something like, most of my students, what did most of my students do? This kind of jumps out to me, right? Most of my students scored in the 50s out of 70. So how did they do in the test? I would say something about that. Most of my students scored in the 50s out of 70 points, but I did have one student who didn't do so well as compared to the others. All right, so let's talk about what's called a back-to-back stem and leaf plot. So that kind of looks like this. So notice if I were to kind of like cover up this, and just look over here, this looks exactly like the stem and leaf plot we were just looking at. So it's like a single stem and leaf. But if I want to compare, in this case you can see on my key, it's the number of sit-ups that we're looking at. If I want to compare the number of sit-ups that girls do to how many boys do, I can make what's called a back-to-back stem and leaf plot. So notice the stems are listed down the center. And the stems are in numerical order too, so like 0, 1, 2, 3, 4, 5, 6, 7, right? And then the leaves go out in either direction. So these are leaves, but these are also leaves, right? So we can kind of compare boys and girls by looking at the same graph. And again, we have a key. So the stem tells us like the tens column, and the leaf tells us the ones column. So a 1 and a 1 means someone did 11 sit-ups. So it's always normally a little bit easier to read the leaves on the right-hand side, but on the left-hand side, if I were to look at like this number here, that 7 goes with this 5. So that means that a boy did 57 sit-ups. So just because the 7 is like more on the left than the 5, don't forget, the 5 is the stem. So that's 57, not 75, okay? All right, so let's take a look at that same back-to-back stem plot, and let's answer some questions. So part A, which gender has a greater range of ability when performing sit-ups? So we're talking about range, right? Biggest minus smallest. So the maximum, the biggest for the girls, is a 54. The lowest for the girls is this one here. That's an 11. So the girls' range is 54 minus 11, so 43, right? On the other hand, the boys, their biggest number, if I go down, the biggest stem is a 7, right? And then it's like a 71 and a 73. So the biggest number of sit-ups here was a 73, and the smallest number of sit-ups here was a 0.7, or in other words, just 7, right? So 73 minus 7, so 66. So which gender has a greater range? Well, in this case, the boys have a greater range when they do sit-ups. And you can kind of see that because the girls, when you look at the actual plot, they're like kind of smushed together. They don't spread out quite as wide as the boys. So range is really talking about like how spread apart the data is. So next question, which gender has the greater median number of sit-ups? All right, so here we're gonna go through and cross off highest and lowest for the girls, and then the boys. So we'll write down the girls' median, and then the boys' median, right? So over at the girls, the smallest is 1, 1, or 11. The biggest is 5, 4, or 54. The next smallest is 2, 2. The next biggest is 4, 6, 46. The next smallest is 2, 6. The next biggest is 4, 3, 43. Then 2, 8. Then 4, 4, 48. Then I go into my 30s. So 33 is the next smallest. 39 is the next biggest. Keep crossing off. So this number here, this is our median. And that matches up with this stem, right? So the median for the girls is going to be a 36. On the other hand, the median for the boys, again, I cross off the highest with the lowest, but be careful, this is a little trickier because these stems go towards the left. So think, just as you're doing this, think about which one's the highest, which one's the lowest, and in which order do we go. So the lowest boy is that one there. The highest one is the 73, right? The next lowest is the 11, the 1, 1, 11. The next highest is the 71. The next lowest, again, think about lowest, is the 21. So cross off that one. The next highest is in the 60s, but is it the 2 or is it the 8? It's the 8, right? The next lowest is 24. The next highest, 65. The next lowest, 26, 62. So how about the next lowest? So again, we're going to be in the 3 column. Is it like 34 or 38? We're talking about the next lowest, so it's 34. And then the next highest is in the 5 column, or 5 row, I'm sorry. We're talking about the next highest. Is it 53 or 59? 59, right? So then 35, 57, 38, 54. See how this gets a little more confusing? And then the next lowest is in the 4 column. Is it 41 or 49? The next lowest is 41, right? Next highest is 53. Next lowest is 42. Next highest is going to be 49. And then 42, 48. And so there's our, there's our median. So that leaf corresponds to the median, which matches up with this stem. So remember, that's like a 42. The stem always comes first. So there's our median. Which gender has the greater median? It would be the boys. And then last question, we haven't really talked about this yet. Does this class contain more boys or girls? So think about it. Each of these leaves represents one girl. Each of these leaves represents one boy. So what you have to do is figure out how many leaves you have for the boys on the boys side and then how many in the girls side. So you're just counting up the leaves. So I'm going to count them up real fast. I'll do boys first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there's 23 boys. And you probably can like eyeball that it might look like there's more boys, but let's just double check. So girls. Remember, one girl did 11 sit-ups, so there's one person. One girl did 22 sit-ups, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So, does it have more boys or girls? It has more boys. All right, so that's our back-to-back stem and leaf plats. So you guys are going to do some practice problems. So pause the video here, try these practice problems, and this worksheet, I think the recording is going to cut off a little bit at the bottom here. So you might want to pull this worksheet up on Schoology so that you can see all the problems at once. So there's a front and a back. Pause the video, try these practice problems. And then when you unpause the video, you're going to come back and I will give you some answers. All right, guys, welcome back. So hopefully you did these practice problems. Take a minute, check your answers. As a quick reminder, when you're checking answers, remember, in a box in Whisker, there's 25% of your data in each section. So 25 in here, 25 in here, 25 in here, 25 in here. Even though it doesn't look even, the percentages are evenly spread out, okay? All right, please make sure you get all your work submitted. If you have questions, please email me. That's all I have for you. Have a great day. See you later.